Hey guys, all right, here we are for the second part of your lesson, 7.2, graphs of inverse functions. We touched a little bit on the graphs in the first lesson, so now let's really dive right into what those graphs are. And that means shortcuts, and who doesn't like a good shortcut, right? So we're going to graph inverse functions and identify the symmetry. We're going to use the graphs of inverse functions to determine domain restrictions. Looking at a graph is a really quick and easy way to figure out what the domain is going to be, okay, or what it needs to be. So it says the graph of a function and its inverse shows symmetry that arises from the relationship between the domains and ranges of the function. So number one, it says find the inverse for f of x equals 3x minus 2. So that means we got a Freaky Friday. So change f of x to a y, switch their places, solve for y. So we got to add 2 to both sides. So we'll have x plus 2 equals 3y. Divide both sides by 3. Split the fraction. And we'll get y equals 1/3 x plus 2/3. So put the function notation back on. F inverse of x equals 1/3 x plus 2/3. Okay, so we have that so far. So it says graph f of x and f inverse on the coordinate plane. Then graph the function y equals x as a dashed line. That's the reflection line, remember? Determine the domain and range of f of x and f inverse of x. So I'm going to start with the diagonal because it's super easy. So we're just going up 1 over 1, so we're literally on the diagonal, up 1 over 1. I'm just going to put it as a dotted line because it's just easier to do dots. I'm going to go all the way edge to edge. When you go edge to edge in a given graph, it makes it look really clean. And I like it when it looks clean. All right, so f of x, I'll do this one in this color, in this lime green. So the y-intercept is a -2 because this is a line. And the slope is a 3, so up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I'm going to go all the way. 1, 2, 3 over 1. 1, 2, 3 over 1, edge to edge. So now go back to the -2. Now go backwards. Down 3, left 1. 1, 2, 3, left 1. 2, 3, left 1. And I'm out of room, so that's as far as I can go. And connect the dots. Why did I put my lid on? And line it up good. Draw your line. Lines have arrows in both directions, meaning they go to infinity in both those directions. Okay, so there's f of x. F inverse, I'll just use the color that I wrote it in. So 2/3. So 2/3 of the way would be right before a 1. It's the y-intercept. And we're going up 1 over 3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Every time I go up 1, I'm just below the number line. 1, 2, 3. That's as far as I can go. And then go backwards. Down 1, left 1, 2, 3. Down 1, left 1, 2, 3. Down 1, left 1, 2, 3. And that's as far as I can go. If your points end up not being in a straight line, that means you graphed them wrong. Just saying. Okay. And that diagonal is going directly across from it. So if I were to take this diagonal and fold the paper in half, it would be the same on both sides. It makes an X pretty much. Okay. So now a line, the green line is the original line. It's going to pass the horizontal line test. It's going to pass the vertical line test. No problem. So its inverse, of course, is going to be a function plus it's a line. All lines are functions. The only line that's not a function is a vertical line. It's undefined. All right, so let's write the domain of f of x. since I don't have to restrict anything, I can use any x value I want to plug in to f of x to find whatever y value. So that means when I can plug in anything I want for x, that means the domain is all real numbers. And we use this fancy looking capital R with the double line thing on the side that signifies the real numbers. So we could put that over here. This equals the real numbers. It's a nice little symbol. Okay. The range has to do with the y's. Well, the y's, any y is going to be used, positive and negative. So the range is also all real numbers. Okay, so there's my domain and range for f of x. For f inverse of x, well, if I were to Freaky Friday these, I don't even need to look at the graph. We just have to switch places, right? That's what we learned in the last lesson. Well, they're both all real numbers, so guess what? These ones are also both all real numbers. Okay, so it says describe the symmetry that you see in the graph from item 2. So let's go ahead and describe that symmetry. These are lines that are symmetric over the line y equals x. So we can say the graphs of the function and its inverse are symmetric about the line y equals x they represent a reflection across this line. Okay, so if you need to press pause to finish writing that, do so now. Otherwise, I'm going to keep going. Next page, page 98. Says you can use the relationship between the domain and range of a function and its inverse to graph the inverse function. Because remember, when we have a function and we find its inverse, all we have to do is Freaky Friday, switch the places of x and y. So when it comes to graphing, we do the same exact thing. Algebraically would be the same as graphically, right? Yes. So it says complete each step to graph the inverse of f of x equals 1/2 x plus 3. Determine the domain and range of f of x and f inverse of x. So it's already graphed for us. So it says step 1, complete the table of values for f of x, then graph the function on the coordinate plane. Well, it's already graphed, so let's find what y value is at -4. At -4, on f of x, -4, well, it's off the graph. Well, what do I need to do? I need to plug it in right here. So if I plug in a -4, half of -4 is -2. -2 plus 3 is 1. If I were to plug in a -2 for x, half of -2 is -1. -1 plus 3 is 2. -2, positive 2, yeah, there's f of x. -2, 2. -4, 1. If I plug in a 0, 0, 3. If I plug in a 2, it's 2, 4. If I plug in a 4, 4, that would be a 5. Okay. That's f of x. This one is f inverse of x. Okay. Step 2, use the table from step 1 to create the table of values for f inverse of x. Then graph the inverse function on the same coordinate plane. Well, it's already graphed for us, so let's not even look at the graph. Just not even going to look at it. Remember, all we have to do is Freaky Friday. So if the x of -4 and the y of 1 switch places, it'll be 1, -4. Switch places with a -2, 2. becomes 2, negative 2. Switch places with 0, 3, becomes 3, 0. Switch places with 2, 4, it becomes 4, 2. Switch places with 4, 5, it becomes 5, 4. Super easy, right? Okay, both f of x and f inverse are linear functions, so the domain of both f of x and f inverse is all real numbers. They're both lines, so the domain and range for both of those functions are all going to be all real numbers. Okay, so that's pretty much all you got to do. When you have a table and you have to find its inverse, you just Freaky Friday all the x and y values, and then you get the new x and y values of the inverse. Okay, so let's do try these A, letter A. We'll put it over to the left. It says graph each function on a coordinate plane, so that's why we need the graph paper side. Then use symmetry or a table of ordered pairs to graph the inverse function. Determine the domain and range of f of x and f inverse of x. Okay, so I'm going to write this down over here, over to the left. Letter A is f of x equals negative 2x plus 3. Okay, and I'm going to use a table of values. And I'm going to use my Fab 5. So the Fab 5 that I like to plug in for x are negative 2, negative 1, 0, 1, and 2. My Fab 5. So if I plug in a negative 2 times negative 2 is 4. 4 plus 3 is 7. If I plug in a negative 1, negative 2 times negative 1 is a positive 2. 2 plus 3 is 5. If I plug in a 0, it wipes out that negative 2, so all I have left is a 3. If I plug in a 1, negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. And if I plug in a 2, negative 2 times 2 is a negative 4. Negative 4 plus 3 is negative 1. Okay, so I have this table of values, and now let's go and graph. So I need my y-axis. I need an x-axis. Okay. So let's start with f of x. I'll let f of x be this nice dark purple color. So I have a y-intercept of 3, 1, 2, 3. And we know the slope is a negative 2, so down 2 over 1. Oops, 1, 2 over 1. Why'd you make us do a table, Mrs. Garcia? Well, because I think it's easier to do the inverse graph when you have a table of values. So all you have to do is Freaky Friday them. So for the other graph, let's Freaky Friday it. So this will be x and f inverse of x. Okay. So if we Freaky Friday negative 2, 7, we'll get 7, negative 2. Freaky Friday negative 1, 5, 5, negative 1. Freaky Friday 0, 3, you get 3, 0. Freaky Friday 1, 1, you get 1, 1. Freaky Friday 2, negative 1, you get negative 1, 2. And then graph those. So 1, 2, 3, 4, 5, 7's off my graph. So I'm going to go to the next one. 5, negative 1. 1, 2, 3, 4, 5, negative 1. 3, 0. 1, 2, 3. 1, 1. So they use that same point. And then negative 1, 1, 2. Look at that. Looks like an X-wing, right? Pew, 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 pew. All right, so also the diagonal, they didn't say to graph the diagonal, but remember the diagonal is on the up 1 over 1 from 0, 0 in both directions. So if we look at that diagonal, it looks like it's cutting it in half. Like I could fold that in half and it'll be the same on the left and the right. So it is symmetric about that line. Okay, so there we go. All right, letter B. F of x equals x plus 6 over 3. Well, we're going to need to split that fraction. So that's a 1 in front of that x, so 1/3 x plus 6 over 3, 6 divided by 3 is 2. Okay, so this time I'm not going to make a table of values just yet. We'll go ahead and graph. We'll put it down a little bit. Okay, and let's go ahead and graph this. So we have a y-intercept at 2, and the slope is 1/3, so up 1 over 3. And I'm out of room, so I can't go any further, so down 1, left 1, 2, 3. Connect the dots, make your line. Okay, there's f of x. Did f of x in that blue color because I like to color code things. You guys know that about me. And let's take a look at what the inverse would be. So I have 3 points there on my graph. I'm going to use just those 3 points. X and then f inverse of x. I'll write the table sideways because I don't have a lot of room. So first point there is a negative 1, 2, 3, negative 3, 1. So Freaky Friday that, and it would be 1, negative 3. So 1, negative 1, 2, 3 would be down here. Take this point. This is the point 0, 2. And Freaky Friday it, you would get 2, 0. It's right here. And then this point is 3, 1, 2, 3, 3, 3. Well, you Freaky Friday that, and you still get 3, 3. Connect the dots. And if we were to fold this in half, there's our diagonal. Imagine that diagonal. Actually, instead of imagining it, let's draw it in. Yeah, if we were to fold a line along that diagonal, the left half would look exactly the same as the right half. So it is reflecting across that line. Looks good. And the only thing we haven't done for A and for B is the domain and range. But it's going to be really easy, so I'm not even going to write it, because the domain and range of lines is all real numbers. Domain and range of lines is all real numbers for the function and its inverse, because they're all lines. Who would have thought? Okay. So let's go on to number 7. You can use the symmetry of the graph of a function about the line y equals x to help you graph the inverse of a quadratic function. Okay, so it says complete each item to graph the inverse of f of x equals x plus 2 quantity squared. Okay, this is obviously a parabola because it is to the second power. And there it is, f of x is right here. I'm just going to trace it in my orange pen here. Okay. It says graph f of x on the coordinate plane, then graph the function y equals x as a dashed line. I know it's already there, but I'm going to go ahead and trace it. There's the diagonal, y equals x. Okay. And it says to graph the reflection of the parabola over the line y equals x. Okay, so when we graph the reflection, it's nice when we find some exact points, like the vertex of the parabola. We have a point at 1, 1 and negative 3, 1. And then Freaky Friday them. The Freaky Friday of negative 2, 0 is 0, negative 2. So negative 2, 0, Freaky Friday, you get 0, negative 2. So I'm going to put FF for Freaky Friday. If I have negative 3, 1, Freaky Friday that, we have the point 1, negative 3. 1, negative 3. Look at that. And then the other point, negative 1, 1, we'll Freaky Friday that, and we get 1, negative 1. And then we have our inverse graph. Okay, this is f inverse of x. Okay, so is the resulting curve from the reflection a function? Explain why or why not. Well, they are inverses of each other, no shadow of a doubt. If I were to fold a line over that diagonal, it would be the same on the left as it is on the right. That is for sure. But is the inverse a function? Does it pass the vertical line test? Nope. So it is not a function. So is the resulting curve from the reflection a function? No. And we need to explain why. So no, because it does not pass the vertical line test. What domain could you use on f of x so that both the original and its inverse are functions? Is there more than one possible domain that would generate an inverse function? Explain your reasoning. So we're going to skip the explain part. We're just going to do it. So there are two possible domains and ranges that we could be using. Okay, so remember, we could chop off the left half, or we could chop off the negative half of the original function. So that gives us two different domains that we could go with. So let's start by chopping off the negative side. So if we chop off the left half, that means that we're using x values from -2 and then to the right. So numbers that are greater than or equal to -2. So we could have a domain of, actually before I write domain, put f of x, domain x greater than or equal to -2, which means the double arrow means implies that f inverse of x's domain would be different. So we'll take a look at what that is up here. So from the graph, if I take off the positive side, the only part that reflects the right side is the top half. So if I look at just the top half of the inverse function, that means that I am using x's from 0 to infinity. So the domain would be x's greater than or equal to 0. Okay. Then for the second part, if I chop off the right half instead, that means -2 is still the number I'm looking at, focus. But I'm using -2 and the numbers to the left of -2 to get the rest of that curve. So for f of x, I would have domain where the x values are, if they're smaller than -2, that means less than. So less than or equal to -2, which implies that f inverse of x, well, if I'm looking at the negative side of f of x, then I'm going to be looking at the negative side of f inverse of x. So the x values I'd be using would still be from 0 to positive infinity. So x greater than or equal to 0. Okay. So no matter what, it would still have the same domain for the inverse function if we use the top half or the bottom half. That's because it's using the same x values from 0 to infinity, top and bottom. It's just the ranges that are different. Okay. All right, number 11, graph f of x, the line y equals x, and f inverse of x on the coordinate plane. Use the restricted domain x greater than -2. I should say greater than or equal to -2. Okay, so on the graph, we already have it there. They graphed it for us. So F is just the left side or the right side of that parabola is what they want. X greater than or equal to -2. So from here to the right, there's F. And then from here, we have F inverse. And then the diagonal. Looks like really mad eyes, mad eyebrows. Okay, so if I just wanted to look at the domains that we restricted it to, we'd have to chop off. The left half was chopped off, so the bottom half was chopped off. So I should only see those mad eyebrows. And if I chopped off the other side, I would just see that. Those remind me of like the Grinch eyebrows. Like, he's very, very sneaky. All right, and that's it. Have a good one, you guys.